everyone. It is really nice to be here with you today, even if only in a virtual format on the screen and not in person. Today my presentation will be about edge computing. I will talk about a few use cases, common requirements, challenges, and I will also introduce you a solution in the open infrastructure space. Before diving deeper, please let me introduce myself first. My name is Ildiko Bancha. I work as Senior Manager of Community and Ecosystem at the Open Infrastructure Foundation. As part of my role, I'm also the Community Manager of one of our projects. It's called Starting X. And stay tuned, I will be talking a bit more about that project a little bit later today. If you have any questions or comments to my presentation, please reach out to me. You can find my email on the slide. I would love to have a follow-up conversation with you about edge computing, your use case, challenges, or the solutions that you're using. So edge computing. The term and the concept has been around for a couple of years now, but I can still hear conversations and debates about what edge is, how big or small the edge is, where it is, and really just what is edge computing. In my personal opinion, I like to look at edge computing as the evolution path and the next step for cloud computing in its evolution. Edge computing really is about taking the concepts and some of the solutions in the cloud space and taking it out to the edge of the network, closer to the end users. And end users can be human beings, but they can also be machines, a smart sensor, and you will see a couple of examples in the use cases that I brought you today. So edge computing really is all about utilizing the resources that we already have out at the edge, a cell tower, your mobile phone, and again, you might have cameras out there, and the cameras are turning into smart cameras, sensors are turning into smart sensors. Sometimes you need to deploy new hardware, and sometimes you can just utilize what you already have out there. And edge computing is about to bring functionality close to the end user, and with that, really bringing IT systems and digitalization to everybody and get really everybody and everything connected. This is where we are going. So what use cases are out there that are under the umbrella of edge computing? The first one, you might be surprised why I even mentioned this, telecommunications and 5G. It doesn't necessarily sound like edge right away. However, they are kind of going and moving forward hand in hand. They couldn't really exist without each other because if you think about it, edge couldn't really exist without connectivity. You need the connectivity between the central cloud and the edge site, or in cases between multiple edge sites, in order to be able to have the full functionality of a use case. So in that sense, by owning, managing, operating, and enhancing the backbone networks and backbone infrastructure for providing connectivity, telecom operators are really the pioneers in this space. And at the same time, they are also utilizing what edge computing has to offer and using the cloud concept and cloud solutions at the edge. For instance, the universal CPE use case is a great example to that, how they are using the small set-top boxes and run some cloud infrastructure services on it so that they can run further applications and provide further functionality to the people who have those boxes in their houses or in the last hop just before the connection gets into the house. So what are the requirements of the 5G use case? Obviously, you need bandwidth, and you also want to have low latency locally to be able to provide functionality. Some of the functions require hardware acceleration, which points towards a heterogeneous environment, both on the hardware as well as the software infrastructure side. And there are different sizes and configurations of data centers as well as edge sites. As you can see on the diagram, we are looking into the end-to-end end infrastructure and solution from the central cloud through the regional data centers out to the far edge. And with that comes a lot of complexity, like how you deploy this infrastructure, how you operate and manage it, how you keep it up to date, how you're patching it, and how can you do all this in an automated fashion. Because with this kind of complexity, you really want a lot of automation. Sending out human beings to remote edge sites or a cell tower that is on the top of a mountain is really not feasible, and it really is expensive, and therefore it is not an option long term. A less traditional use case is industrial IoT. It might not be super surprising, that is on the slides. As we are moving from Industry 4.0 over to Industry 5.0, it really is the era of digitalization, automation, um, even more automation on the factory floor itself. And with that, you really need not just low latency, but be able to provide real time functionality. Because the robotic arms and the large machines, they are usually operating on high speed. So if there is an issue that needs interaction, or you need to stop the system, um, the robotic arm has to stop, either because it's damaging materials, or because it puts someone who's operating the machine in danger. You have to do that in real time. These are all mission critical systems, to avoid risking a human life or the safety of a person, or having a lot of loss because of all the materials that gone to waste. Um, the industrial IoT use case is kind of similar still to the telco one, in terms of some of the applications will need hardware accelerators. In these systems, you usually want to have some artificial intelligence and machine learning applied, um, as well as you need to be able to tolerate connectivity loss and disruption between the edge and any regional or central cloud that is probably providing additional data processing and analyzing how optimal the factory floor is. However, some of those feedback, information, and results are not critical to the immediate operation of the factory floor. The third use case that I have for you is agriculture and aquaculture. And what I wanted to highlight, and what the diagram is all about, is a shrimp farm. Now, this gets a little bit surprising. It's not something that you would naturally think about as an edge computing use case. However, it is a little bit similar to the industrial one, in terms of digitalization and automation really is starting to get into every single industry segment. Everything gets automated. We are using machines, robots, computers, more and more. And with edge computing, all these solutions can be connected, and they can be connected to a central cloud and can be operated either from there, or their data can be analyzed centrally for further optimization and evolution of these solutions. And agriculture and aquaculture are no different. So when it comes to shrimp farms, we are not able to automate how we manage the life cycle of the animals from the larva phase through up until harvest. And with sensors, we can monitor the ponds, the water, the environmental conditions, the weather, as well as with further systems like camera surveillance. We can also monitor the whole environment and make sure that no one breaks in to steal something or disrupt the environment or damage the animals or any equipment. The shrimp farms, kind of similarly to the industrial use case, need to be able to operate autonomously. Like if there is a connection loss between a central data center and the edge site, we cannot allow the edge site to lose functionality because that would put the animals in danger. And for this, again, AI and machine learning are techniques that are getting used out there, like analyzing camera feed real time. And for that, again, hardware accelerators are coming to play, which again leads to heterogeneous environments. So a little bit of a summary of these use cases, which are kind of different but still similar. You can see how the configurations are different from edge side to edge side. You will face with heterogeneous platforms in most cases and mixed workloads. And in most cases, the size of the end-to-end geographically distributed infrastructure is massive. So these infrastructures are going to massive scale, which means that you need a lot of automation and you need to be able to manage the edge sites remotely. It's just not feasible to take care of them through manual labor. You cannot send out a human being to every single edge site to, for instance, carry out an important security patch. That's just not something that is doable. And on the infrastructure side, interoperability is key, and it is a requirement that is kind of getting back into the spotlight because your infrastructure will be growing organically, and you have to be able to plug in new sites, new components, and new solutions. So what choices do you have, for instance, when you're trying to decide what architecture to apply to your use case and solution? There are two main options to choose from. One is a centralized control plane scenario where your control services are centralized and the edge sites that are connecting to the central side are running only the services that are required to run the workloads. It is less operational overhead. However, if you're losing connectivity between the central site and the edge site, that can be a problem because the edge sites will be running with limited functionality. However, most probably the workloads that are currently running will still be available. The other case is when you're running some of the control services out at the edge, which is kind of a distributed control plane scenario. Where you have more autonomy at the edge. So if you have a connection loss, the edge sites are still are able to probably provide most of the functionality that you have out there. So if autonomy is key, then you have to sacrifice in terms of losing some footprint and resources because of the need to run control services out at the edge, as well as having a higher management overhead. So now that we talked about use cases, requirements, and architecture options, what is out there in terms of infrastructure solution? There are multiple projects and solutions that you can choose and pick from. Today I brought you an open source project. It is called StartingX. It is a fully integrated cloud platform that is optimized for edge and IoT use cases. And StartingX is not just an open source project with open source code, but it is also an open community that you can come and participate in if you're using the project already or interested in and have any questions. So what do you need to know about the project on high levels? StartingX is integrating a couple of well-known open source components that you probably already know. Examples are OpenStack, Kubernetes, Linux kernel, libvirt, Ceph, and there are some more projects that you can see on the slide on the diagram. But beyond these projects and their well-known interfaces that you're probably already familiar with, StartingX is providing the functionality that is crucial for an infrastructure solution to run edge workloads, which is to be able to handle complexity and not just the complexity of the workloads, but also managing the infrastructure itself. So StartingX provides you with the capability of managing your hardware infrastructure as well as your software infrastructure by running the infrastructure services and containers, and with that providing more flexibility and manageability. as well as providing you with functions such as fault management, patching, managing the life cycle of your software components, managing the configuration of the system, and more. And with that, Starting X really makes it easier to manage your distributed infrastructure. On the deployment side, Starting X can be deployed in the central cloud, and then you can deploy the edge sites, various sizes with various configurations. If you have enough resources and need high availability functions, you can deploy control services on multiple servers, but you can also run the required services on a single server if you have a small footprint. You also have the option to run a fully container-based edge site with only containerized applications. The key and really the flagship feature of Starting X is the distributed cloud architecture, which I really wanted to highlight because that is following the distributed control plane scenario that I talked about before. And with that, Starting X provides you some control services out at the edge. And if you lose connectivity, the edge site will still operate with autonomy. But when the connection is built back, then the control plane services and the system controller in the central cloud will make sure to synchronize data and metadata between the sites as required. So you have a seamless operation, as well as the distributed cloud architecture makes it easier to manage the edge sites, both from deployment perspective as well as the lifecycle management of the services. And all that Starting X does with well-known interfaces through REST APIs and layer 3 connectivity. The latest release of the project is the 6.0. And it is already running in production at multiple telecom operators such as Verizon, Vodafone, and T-Systems. The 6.0 release has a few enhancements to the distributed cloud architecture, like an easier way to manage disaster recovery scenarios and scaling in and out your infrastructure so you can really tailor it to the load that you have at a given time period. Starting X has support for real-time kernel, and as you can see on the 7.0 side, which is the current release cycle, Starting X supports features like the precision time protocol. So Starting X is prepared to provide a platform for real-time and mission-critical applications like the industrial IoT use case that I talked about before. And during the 7.0 release, there are a lot of enhancements coming to the precision time protocol functionality, distributed cloud, as well as, for instance, enhancements to the Kubernetes component. The 7.0 release is supposed to come out really soon, so you only need to stay tuned for a little bit longer. But you can also find the release notes, documentation, and links to download and try out the 6.0 version of the project if you're not using or evaluating it yet. And as I mentioned before, Starting X is also an open source community. So I would like to encourage all of you to get involved and get in touch with the community. You can find them on IRC for synchronous communication, or you can reach out to them on their mailing list or join one of the community calls. And you can find information about all that on the links on this slide. And where can you meet the community? There are a couple of Open Infra events that are coming up. We just had our summit in Berlin, the Open Infra Summit, so you should be able to find some materials and recordings on YouTube and online platforms. And if you're interested in updates about Starting X and the Open Infra communities, then you can tune in to Open Infra Live, which is an online show that runs on Thursdays with topics that feature Open Infra communities, such as Starting X, as well as some others like OpenStack, Zool, Kata Containers, and more. Discussions with industry experts and further topics, use cases, case studies. So if you have a topic idea, please reach out to us and share your idea on ideas.openinfra.live. And if you would like to meet the contributors in person, then our project teams gathering event is returning in person later this year in October in Columbus, Ohio. This is a contributor focused event, and it is full of discussions to plan roadmaps for the upcoming release cycles and have discussions about new and exciting features, priorities, and further more technical topics and some enhancements to some of the processes and tools that the communities are using. You can find further information about the event and updates on the event website. And I would love to encourage you that if you have the opportunity and possibility to travel, please come and meet our communities at the Project Teams Gathering event in October. And with that, I would like to thank you for your attention. Please reach out to me at ildico@openinfra.dev if you have any questions about starting X or edge computing, or would like to have a conversation about anything that I talked about today. Thank you.